Hello.
Okay. Need my notes? I think I might need my notes. I think I'm okay. All right. Here's our. I can't believe we're at the end of the trip here. This is our 8th speaker for celebrating the 7 Turing Awards that were done at Berkeley, saving the best for last. Andrew Yao. So Andrew was born in Shanghai in 1946. So do you have siblings? And what about the education of your family, your parents and your siblings?
I have a brother and a sister, and my brother was in the IT business.
Oh.
He worked for a while at Bell Lab, but now he's into real estate.
Real estate. in where?
In New Jersey,
New Jersey.
And he works with my older sister, and I think she's a mogul.
And she's a mogul? a real estate mogul?
Well, a small one, but it's...
a small mogul. Okay, and then, and so I gave a talk last week at Tsinghua, and Andy generously brought California weather to Beijing. It was blue skies, sunny. So in return, we brought Beijing weather for you. Where it's, you see people in masks just to make Andy feel comfortable and many of his guests to be able to do that.
Yeah, I think this morning I saw there are people walking with masks.
Yes, that's just for you. That was just in your honor.
That's what I thought.
Yeah. So you grew up during the Cultural Revolution. So let's try this, because some of us are older than others. How many people know what the Cultural Revolution is? Okay, good. All right. So it was from 66 to 76, getting rid of capitalism out of China's culture pretty harshly. So how did that affect you and your family?
Not at all, because I grew up in Taiwan.
Ah. So, so when did your family move to Taiwan?
We moved to Taiwan around 1950 or so. So
right at the end of the war, right?
That's right. That's right. I think we kind of escaped.
Escaped? Okay. So you followed Chiang Kai-shek to Taiwan.
That's right. But wow, I would say that my parents followed Chiang Kai-shek to Taiwan.
You didn't have a lot to say as a 4-year-old. So then you're in Taiwan and you get. You study physics from National Taiwan University. Why did you pick physics?
Because physics is fascinating. I read an introductory book on relativity.
Ah.
I think it's, if I remember correctly, it's by Lord Eddington, kind of saying that it's an introduction to relativity. And somehow it fascinated me because it talk about the essence of relativity as deducible for experimental evidence. Everything is a Gedanken experiment. And so so I thought that's cool. And so I decided that I should try to do the same thing. And well, I ended up a computer scientist. So what did that say about my judgment?
Yeah. Well, then you didn't give up, all right? You got your bachelor's degree, and then you went to Harvard and got a master's and PhD in physics. Then, and for those of us who have suffered through graduate school, whether or not you get a PhD, after he got his PhD, he decided, that was fun. I think I'll get another PhD. So what was that decision like? You got your PhD in physics from Harvard, and then you decided to get a PhD in computer science at University of Illinois at Urbana-Champaign. So how did that decision happen?
After my PhD degree, I got a job in Santa Barbara as a postdoc. It's a 2-year job.
At UC Santa Barbara?
At UC Santa Barbara. And after 1 year, after working with the very nice professor there, I decided that I was not creating relativity and I wasn't doing the foundation of quantum mechanics because those were the things that attracted me to physics. And at that time, my wife, Frances Yao, who was a student of Michael Fisher and at MIT, so I got introduced to the preliminary drafts of the book by Donald Knuth.
Oh, volume one.
Volume 3 at that time. I mean, he already had some initial chapters circulated, and I look at that. I say that looks like fun, and then I realized that computer science was a very young discipline, and now by hindsight, it was really young because computer science, the first computer science department was started at Purdue. That's kind of in the 1960s. So that was just, about 10, 15 years within the establishment of the discipline. And so I thought this looked like the beginning of something great. It's just like in the kind of in the 1900s that it's just the beginning of quantum physics. So I thought that there seems to be a lot of things that one can do, and it's a sort of thing that you can do without too much background. And so I decided I would take my luck, and after all, getting a PhD really seems to be very easy because once you know how to do research. I think doing what discipline doesn't really matter too much, so I decided I want to do it.
Okay. Yeah, well, one of my questions is when you met your wife, Frances Yao, who's also a computer science theorist. I thought you met her my guess was you met her at UIUC, but did you met her before?
No. It's I think if it were at UIUC, yeah, I think it would be against the ethics. So, because she was a faculty there, and I was a student.
Oh, okay.
And
she'd go to jail. Then.
That's right. So actually, we met in Cambridge, Massachusetts. She was a student at MIT, and I was a student
at Harvard.
Graduate at Harvard.
You were in physics, and she was in computer science.
That's right. So that is a very natural place to meet for people from several thousand miles away to have to meet there. It's sort of like salmon. It's like some animal thing.
Was she born in China too, or?
That's right. She was also born in Shanghai. So
also in Shanghai.
And also we didn't know each other.
So you met 5,000, well, more, 6,000 miles away. All right. So you decide to get your PhD in computer science, and you go to UIUC. Why did you pick UIUC, or did you apply elsewhere?
Yes, I think it's actually quite interesting. I think that after I decided that I should quit the postdoctoralship, and we look at Harvard, and Harvard has a rule saying that you cannot get a second PhD degree.
Right. Understandable.
And now we tried MIT, and a professor there, whose name I forgot, and he said that he told Francis, he said that is your husband a perpetual student?
Yeah.
Okay, so that I think that's discouraging enough. Uh-huh. And then Francis received an offer at UIUC to become a faculty because she was a year behind me, and she asked them that, can I take my husband along to be a graduate student? They said that, of course. I mean, that's how I.
That's how you got in. Huh?
That's right.
She snuck you in snuck you by the guards at the door, and got you in the graduate program. Okay. That's okay. And now what I've learned, you'd think I would have known this, but I learned from my visit to China, is for reasons I don't know. I guess because Americans can't pronounce Chinese names, that people pick an English name. It's not a given name. So Andrew was a name you picked, is your English name. Why did you pick Andrew?
Well, you know that I was at one point a Catholic.
Okay.
And so as a Catholic, you had to have a name.
Oh, as baptism?
Baptism. Oh, it's not, I don't, I think it's not baptism, but somehow you got a name. At least that's the way it was.
That's what your parents told you?
Yeah. So,
but you got to pick the name?
I didn't get to pick the name.
Okay.
I think that in our parish, the father, I think that for simplicity, he just say that depending on, he just has 3-4 names. So for every boy is an Andrew, every adult male is Joseph, every adult woman Maria, and so on. So he has a way to make things simple for himself.
So the priest simplified naming convention. All right. So, but by the way, so I've decided, since Andy generously made me a member of the Tsinghua community by giving me an honorary degree, I'm going to try and find a cool Chinese name to go.
Well, I think that Francis would be very good in finding a good name for you, because Donald Knuth's name was given by Francis.
Oh, it was. He has a Chinese name.
The Chinese name.
Oh, great. All right. That sounds like a great precedent. Okay. All right. So next comes a remarkable, so he graduates, and then is a remarkable set of transitions. So 5 universities in 11 years after his PhD. So assistant professor of MIT, assistant professor at Stanford, professor at Berkeley, professor at Stanford, and then Princeton University. So not surprisingly, and then he gets stuck in New Jersey for 8 years, just without moving, and then moves to Tsinghua, where he founded the Center for Advanced Study. So in those American years, when you made all those transitions, why?
I think everything has a perfectly good reason.
Okay.
So, at MIT, that's my first job in computer science. And so somehow MIT offered me a good job. So I went there.
Great place to go, yeah.
Yeah, and now after 1 year, at that time, we lived actually in Providence. My wife was
so Providence, Rhode Island, if you don't know
Brown.
geography, is 60 miles away?
60 miles.
Yeah.
And so now, after 1 year, Donald Knuth traveled to Brown University to give a distinguished lecture speech. And afterwards, we took him to dinner, and he said that, Andy, would you be interested in having a kind of 2 jobs at Stanford to make life easier for you?
You mean one for Francis, one for you?
That's right. That's right. And because that's pretty unusual.
Yeah.
In those days, and so I said, why not? I think because commuting is really killing me. The between
60 miles.
60 miles. Yeah. But now, I mean, I think that's an interesting pattern. So we pack up and move to Stanford. Now at Stanford, so we both became assistant professor, and now after a few years, I thought I should be tenured. So I think by Stanford standard, it's 1 year ahead, and so I just couldn't stand it because all my friends.
All your friends were tenured.
Had tenure.
Yeah, and you didn't. So you were the laggard.
Yeah. So I
bring it up the rear. Okay.
So I brought up so at that time I said that, well, since the university is considering this matter, I might as well go out and look for jobs, kind of other job opportunities, and I got a lot of offers, and actually at one point I accepted a full professor offer at Harvard, and then Dick Karp called me up because I was talking to I asked Dick Karp saying that I would be interested in a good tenure job, and now so Dick Karp called me up and said that we could also offer you a full professor at Berkeley. I think. And my wife said that you have to take this job.
Okay.
Because we live in Palo Alto, and if I kind of flew away to Harvard, then that would be several thousand miles. And so I said that I think it makes sense. So I have to call up the Harvard
Your alma mater.
Paul Martin, saying that I said that I'm sorry, but I changed my mind. And so I came to Berkeley for the year 1981, starting in 1981. And now, I think it was a wonderful year, and as you will hear in the lectures, I think I really enjoy the...
Yeah, when we organized this lecture, and it was John Ousterhout made the observation, he said there were 6 Turing Awards that were done here, and Umesh pointed out that of all, in those 11 years, Andy Yao's most productive year was at Berkeley, and that's where he did the work that led to his Turing Award.
Yeah, so I think after 1 year, it's really another syndrome of the commuting fatigue, and so I went back to Stanford, and then after a few years, we bought a house at Woodside, kind of
near Palo Alto.
Near Palo Alto, and the housing price was horrendous, at that time, and so we paid most of our income on feeding the mortgage.
Mortgage is paying the mortgage. Yeah.
And I complained to Stanford. I said that I couldn't live on Stanford's salary. And they said that, even very senior people like Knut and so on, I mean, they didn't earn much either, so why should you complain? But I said that, I mean, I don't know how they do it, but I have to find a better job. That
higher paying job.
Higher paying job. So I at that time, Princeton in 1985 just started a new department to split from the EE department, and they had only 7. So they only had 7 faculty, so they were trying to hire people. Tarjan already was recruited there, so Tarjan called me saying that why don't you come here too? And I said, do they pay well?
This is Princeton.
That's Princeton.
Probably the wealthiest private university, or in the running. So yeah.
So that's how I got to Princeton. And
Okay.
So that's how everything is rational.
Okay, I agree. All right. In 2004, you're called back to China, or you're recruited back to China. So is that patriotism? Because Tsinghua, as nice a university as it is not competitive with was not competitive with Princeton in computer science in 2004. What happened there?
I think mainly. Well, firstly, Princeton is an awfully nice place, and I have to correct you. I worked there for 18 years. So
18 years. Maybe I can't do arithmetic. Yes.
Yeah, it's not.
That's right.
It's 18 years.
Yes, you're right.
And so by the law of large numbers, I kind of know what the next 10 years would be like.
Given an 18-year sample, you knew what the next 10 was going to be like.
That's right. That's right. And also I have been teaching, met a lot of the students from China in computer science. And many
who came to Princeton?
Who came to Princeton and in other places, and they all came from really top schools, Peking University and Tsinghua, and they are awfully smart people, but sometimes they had to struggle for the first few years, and it's because they really didn't get good instruction.
Yeah.
For undergraduates. So I say that that I would be you'll be a much better use of my experience to go to China, and so that's the main motives. So
was it patriotism or just wasted manpower?
Yeah, I didn't feel that strongly about that emotion. I think the emotion was much more that how can I better use my knowledge and I mean, how can I make a big
impact.
difference in the world?
Yeah, should I keep doing research at Princeton or go to China and help?
That's right. And so and also the other thing was in my mind is that I really hope that China can build up a really state-of-the-art computer science department. And somehow naively I thought that should not be too hard to do.
Wow.
And
I think I'm an optimist.
and mainly, that my sample point was the following: that I was hired to Princeton, 1986, and they were starting with just 7 faculty.
Right.
And now after 6-7 years, there was this, I think it's a NRA report or CRA. I mean, there's a
right, a National Research Council.
National Research Council report.
Rating computer science departments.
And Princeton, just within 7 years, was up to number 6 or number
right.
or something. And so I thought, gee, that was easy. So I thought that maybe I could do the same thing in China. And now it's been 15 years, and it showed how wrong I was.
Well, well, how many of us have visited, maybe, how many of the faculty have visited Tsinghua? I think, yeah. So Tsinghua is the MIT, calls itself the MIT of China, but the non-NDIO part of Tsinghua operates promotions based on seniority. So it's based on years of service, right? So the salaries are associated with years of service, as opposed to the difficult tenure model and track record based on promotion. So NDIO went to this, organization that's been around 100 years and decides he wants to change how it runs. So, what was that like?
I think that I had a somewhat more restricted ambition. I wasn't planning to change Tsinghua, but rather I had a small model, namely that I would like to carve out a little space where we can form our own environment. As it's sort of it's like an oasis, and kind of use the ask the university to give us the freedom to do what is normally doing in the West, and I think the university leaders, they were kind enough to allow me to do that, and so that's what I've been doing. I think that in the meantime, the Tsinghua, the university as a whole, has gradually changed. So
your oasis has influenced the rest.
No, I wouldn't take credit for that. I think they wanted to do that anyway, except that we were in the spearhead of that. So I think that they have essentially made the transition to a tenure track system. At least in terms of the formality, it's very much look like the Berkeley.
The rules look like it.
And exactly whether the implementation fits the spirit, I think that time will tell.
And so I would clearly, your center is a huge success. When you visit there, the Chinese students proudly refer to themselves as the Yao class of 2018, or the Yao class. Maybe I should know. How many people here are members of a Yao class? All right. But getting in, this is at freshmen in college. They compete highly to be there. And when I visited there a while ago, everybody knows what Michael Jordan, the basketball player, not our Michael Jordan. Everybody knows. Well, there was a saying when he was a basketball player, is to be like Mike. I want to be like Mike. So there, I would say in China, they want to be like Andy. So when I visited there many years ago, they all wanted to do theoretical computer science, 100% theoretical computer science, because Andy showed them you could be successful doing that. Are they more diverse now, or still pretty much theoreticians?
I think that by and large, the students in Tsinghua University in computer science, they are pretty pragmatical. They are working on AI. You know?
Okay. They want to do AI.
I think architecture is a hard sell.
Yeah, I agree. I agree. But on the other hand, I gave 6 talks last week, and all over China about the opportunity in architecture. And the talk I gave here is that, like it or not, if we want computers to go faster, we're going to have to innovate in computer architecture. You can vote against it, but it's just not going to happen. So, it's important to have architecture, which traditionally was not taught at Chinese universities. That, for whatever reasons, they would teach data structures and theory and everything else, but computer architecture just didn't make it to the curriculum at most universities.
You know, that I hired your student, Dr. Xu Wei, and I gave him the charge saying that you should make system a major area in our institute.
Yeah, so just get a really great assistant professor and give him all the work to do, and then stand back. But he's done a great job. So getting on to your research, there's a principle named after you. And that's pretty cool, the Yao min-max principle. And that was a result you got really early in your career, and like 2 years after your PhD, right? So did you realize at the time that was a significant result?
Yeah, I liked it a lot, but I didn't think it's going to be one of my main representative work.
Okay. And there's another one, for me as an outsider, is you characterize the millionaire's problem, which is how can 2 millionaires figure out who's wealthier without telling each other how wealthy they are? Is that right?
That's right. You got it exactly right.
And that's also a lot of people are excited about that.
I thought that name would actually be remembered.
Yes, okay. See? Very important. I think there's a theme here that you need to pick good names to market your ideas. But the work that you did that led to the Turing Award was the work you did at Berkeley, which was the pseudo-random number generation and cryptography. Is that right?
I think that certainly at the time of Turing Award, that has had the most impact among at least the theoretical computer science community.
But how about since then? Is there other result? Is that still the?
Yeah, I think the Millionaire problem actually is a special case of something called multi-party computation, and I kind of raised the concept. It's really for theoretical reasons, just aesthetically. I mean, wouldn't it be cool that if you can do a computation so that nobody has to review anything except that you all get the final answers during the distributed computing process. So that turned out to later on to become a pretty big area in cryptography, but still mostly it was a theoretical type of work. But the Fintech came along, and suddenly...
Fintech, which I guess you attend the World Internet Conference, and Michael Jordan and I appeared in Fintech, which is financial technology. It made sense for Michael Jordan. I don't know why I was there. But Fintech is technology for finance. But go ahead.
Yeah, so people have a renewed interest in multi-party computation in the practical sense, because if you want to make things like blockchain really useful, you have to be able to do encryptions such as the multi-party computation. So now a big effort is going on in making not just the multi-party computation, but a lot of the like zero knowledge proof, or the nice cryptography concept that Berkeley has a big part to do with initiating many of the concepts there, and so I think that the next 10, 20 years, it's quite possible that the big thing to do in the theory community is not just to invent new concepts, but actually to make all this treasure, to make them practical, and because it makes a big difference in the world.
Great. All right. I think with that, I'm ready to open up for questions. And all we need is the first question, and the rest flow. Okay. Do you have a microphone or no? Okay. All right. I have a microphone. Either meet me. Want to come up? You can come forward. You go.
Yeah, just would you mind elaborating on, according to your experience, what's the biggest difference between the research and education in computer science in China and that of US?
I think basically, certainly 20 years ago or even 10 years ago, the difference is huge because China's certainly in education, the quality of undergraduate education, the courses, I think they were very much behind the times because they didn't really update the curriculum as often as it should in a rapidly moving field like computer science. And part of the reason for that was that all the Chinese researchers and professors, they would like to produce research work, to bring in projects that bring money. So people were recognized for their research output, the number of papers and so on, but not very much in terms of how well you teach your courses and how well you educate your students. So I think that when I went back to China, I think that the education was not very good, but I think that they have put a lot of emphasis into the idea that actually the basic function of a university is to educate your undergraduate students. I think that they are trying to fulfill that kind of a vision, but it takes, I think it will take a while.
Okay, other questions? Okay. Come closer. I could throw the mic here. All right.
So you've recently taken an interest in blockchain, and I was wondering what, as a theoretician, interests you about that technology?
I think blockchain actually offers just a tremendous, very exciting stage for theorists to work on. I think it's for two reasons. Firstly, you know that people have worked a lot on the interface between computer science and economics, for example, in mechanism design and in auctions. But in my view, that kind of research, while the subject is interesting and there are many pretty results, but I think that eventually the impact will be limited because mainly because the economists hold the value chain. It's whatever work you do, the economists have the final say on is this an important work, is it a good work, whether it should be it will be used by when the English Treasury want to sell bonds, whether they will use your mechanism or not. I mean, the computer science, you can do the work, but you have to kind of to hope.
So
and
the
be appreciated.
economists are the gatekeepers then.
Right, but the fintech is different in the sense that the role of technology is much more the driving force in it, and somehow the financial people they have to take it whether they like it or not because the competitive pressure. So therefore, the theorists now, if you do something nice and something that makes sense, and especially if you know something about the financial side, then you hold the value in your hand. So we would be, in a way, to kind of to drive the fintech forward. So that's the number one reason that it's important. And secondly, I think the problems are very interesting. If you look at even the very simplest thing that when you look at the Bitcoin system or you look at the goes through and it's very non-trivial to show the convergence and to show the consistency. And all those were things that kind of we like to do in distributed system, in the theoretical computer science, and you do things. But so the problems are as challenging as we have encountered before. But this time, the difference is that it really makes sense. Whatever you do could become really important. So I say that the blockchain and this kind of related area of the theoretical distributed system and plus cryptography research area, I think that if I were young, I'm already doing it, but I would say that if you're young and ambitious, you should don't just try to do things in the same old-fashioned way. I mean, don't try to bring some more clarification of some old concept. You should jump into a new field because in the new field, you can really show your talent and your creativity and actually will be remembered.
And just as a point of order, our second speaker, Silvio Macaulay, he gave a talk that was based kind of on the research he did here, but his alternate talk is on Algorand, which is his version of a blockchain technology that he thinks is much better than all other blockchain technology. So two of our Turing Award alumni are doing research in the blockchain and theory, and both with believe they can have big practical impact on the world. Okay, it looks like another person, Chuck in the back, who was at Tsinghua last week as well.
Yes. Okay. Actually, Dave, I wanted to ask you this question last week at Tsinghua, but I didn't get a chance. But I actually want to ask you and Andrew and also Dick, actually. I'm so happy that Dick is here as well, which is, I actually flew in today, by the way, from Asia. And I'm so happy that I could make this, to come join this. But great, thank you, Andy, for the great sharing. And thank you, Dave, for such a wonderful moderator. My question is this, why is Berkeley so innovative in terms of the research that we've done, and that we actually have so many Turing winners, right, produced out of Berkeley? So it would be great if you guys, can comment on that. Dick, please, start.
Well, in my experience at Berkeley, one of the greatest advantages is that in any area that I might be interested in, the best people in the world are already here. And so it's a self-propelling process. And, talent attracts talent. The other thing I think that we do in computer science is that from the moment that a young professor is appointed, that person is a full citizen, and everything possible is done to help them advance their careers. And we're delighted when we can confer tenure, whereas in some other universities, it's dog eat dog, and only a handful get the tenure.
Very good, thank you.
All right, you want to take that one on, Andy? You want to? You certainly have experience at a lot of institutions.
Yeah, I think it's a mystery why Berkeley is such an innovative place. I think that every time I come back to Berkeley, I think it's just like this morning. I just walk around. Somehow this campus, there seems to be a magic there. That when I'm here, that my mind seems to work better. That you start to, I don't quite understand it. You know I was here the last time.
It's the ash. It's the ash in there.
Yeah, the last time I was here in for a whole semester is in the spring of 2004, and that's when I started thinking about problems in auctions, and so I was thinking about a really hard problem, and I spent whole semester on it, and somehow I think that if I didn't come to Berkeley, I wouldn't have been able to solve it. I think it's just that every campus has a atmosphere, and somehow when you walk around campus of Berkeley, there is a combination that makes you want to do great things. So I cannot explain any better than that.
So I've been, ever since Ousterhout told me this observation, which now is at least 6 months, I've been puzzling this over. So here's the things I think. Partly it's what Dick said about the campus. So when Berkeley was a sleepy campus before Clark Kerr, and if we, a bunch of faculty read Clark Kerr's book and met with Clark Kerr, and one of the things that happened in the transformation was Clark Kerr was at some presentation, and he said, we think Berkeley's going to become a much better place than it's been in the past, and there are a bunch of people from Yale who kind of, teased him or insulted him and really pissed him off. But he came back and pretty much filtered through the faculty in all the departments, and the people who weren't doing great research, he got rid of and replaced them and put him forward as director. But partly what was here were the physicists, right? The Manhattan Project physicists, the Nobel Prize winners. And so these people, when they reshaped the campus to be a great research campus, knew what it meant to have impact. And that's what they valued. And we were going to be a campus that valued impact. And the thing that Dick Karp said about young faculty, this is a campus policy, which I've learned from being on the budget committee, of trying to hire great young faculty and nurture them. And so what Berkeley is a place is, if you're an institution that likes to wait for people to be famous and hire them, you raid Berkeley, because we're a generator of great people, right? So computer science is a field that's a young person's field. I think if it's like history, where things change, you need to read thousands of books, that's a slow-changing field. We're a fast-changing field. So being a place that's great for young people in a young people's field because it's fast-changing, that was an asset. So that was a plus here. We were, the people who kind of shaped this department, like Donald Peterson, had this idea of collaborating with industry, not so much competing with industry, and open source. Donald Peterson with the SPICE program did open source, so that was part of our culture. We shared things. Silicon Valley was clearly an asset to Berkeley. But then the question is, what about Stanford? Well, Stanford did not have the policy of hiring great young faculty and promoting them. So there were 3 people who were assistant professors at Stanford that did not become associate professors at Stanford that won Turing Awards. Nicholas Wirth, I'm going to forget somebody, Vince Cerf, and Raj Reddy. They all were assistant professors, did not become tenured faculty, and won Turing Awards. Had they stayed, Stanford would have 3 more Turing Awards, right? And they would be comparable to us. And so it's something about the setup, because I thought I was chair, or CS associate chair in 1990, and in 1990 we'd had 7 projects that were going to get Turing Awards. Well, a couple had already been announced, so Karp's and Kahn's by 1990, 2 announced. And my problem was the public perception that Berkeley was not the top 3 departments. My problem as chair was to get the word out that we're better than we used to be, so please think of us being in the top, that there was a big 4, not a big 3. I successfully was able to convince the world of that, but that was our problem. So Berkeley always has problems. You know, financial problems are the norm, but we continue to do great stuff, right? And despite all the obstacles of the state or the campus, you know, we're always in a crisis, but nevertheless, maybe there's something stimulating about the crisis. And, you know, giant class sizes and all that stuff, but yet these great things happen. I'm fully convinced that the 7 awards is not the last Turing Award that's coming to Berkeley. They have this 20-year pipeline delay, right? 20-stage pipeline every year. So it's a while. There's more in the pipeline. It's going to take a while for them to pop out. But it's, you know, maybe it's a delicate ecosystem. I don't, you know, but we have quantitative evidence that we're different from everybody else, and if for that observation to change, you know, for somebody to catch up with us, it's going to be decades to catch up, and they may never catch up because I think I think more of our colleagues are going to do it. So that was my short answer to that question. But another Turing laureate has a comment. Velvicon.
Well, what I want to do is tease apart something that Andy said, which was that in China, apparently, they have a policy that the purpose of the university is to teach undergraduates. Now, that's not so different from what we have here. This is a state-funded university. I really should say a state-underfunded university, because the share of funding from the state has dwindled over the 50 years that I've been here. It is our duty to educate undergraduates when viewed from Sacramento. But that's not why we're here. The most important things that can be done at a university by its professors is to detect, recognize, and cultivate talent. That's really the job we have to do, despite that we're underfunded to do it. And so we do it despite the obstacles. And that's what makes a university great.
Okay. All right. I think with that, I think that's a great way to end. Thank you very much for doing this. Thank you. So, talk today is at, you know, reception at 3:30, 4 o'clock. This one's across the street. You know, you have to keep track of where it's going to be. But it's sure to be exciting.